quick recording about solving absolute value equations. And first of all, I wanted to remind you what absolute value bars look like and what they do. So these vertical bars together are a form of grouping symbol, and typically we're told they are the distance from zero, and you can never travel a negative distance. So when you have it evaluated, it should never end up being a negative. So the absolute value of -3 is +3. Absolute value of +5 is +5, and so on. You likely remember these from before. The one that people sometimes forget is that the distance from 0 is 0 for that. An absolute value of 2 is 2, as well as the absolute value of -2. So those last couple there are what lead me into this idea. So this equation is basically saying we are traveling 2 spaces from 0. Now, if you were going to travel 2 spaces from 0, you would end up at +2. You would also end up at -2. Visually speaking, that's where we are. All right. Now, if we use some algebraical reasoning, we just said the absolute value of what is 2. And up here we said the absolute value of 2 is 2. But also we notice the absolute value of -2 is 2. And so most of these types of equations end up with 2 different equations and solutions. Okay? So if I had the absolute value of x plus 2 equals 3, I think of it visually. If I'm traveling 3 spaces from 0, I could end up at +3, or I could end up at -3. Okay, so my steps for solving are in the red box at the right, and it says we're going to isolate the absolute value. So in these 2 examples so far, it's already isolated. We're going to set up the 2 equations. Most common, we're going to have 2 equations. Again, whether I'm going in a positive direction or negative direction. So whatever's inside that absolute value could equal. Then we're going to solve both these equations and, of course, check our answers because sometimes we could end up with no solution. All right? So next, we have to solve this first equation on the left. So I'm going to subtract 2. I have x equals 1. If I subtract 2 here, I have x equals -5. Okay, now I should be checking my answers, which means if I go back into the original and I take my 1 plus 2, well, 1 plus 2 really is 3, and the absolute value of 3 is 3, so we're good with that. If I take my -5 and I add 2 to that, I get -3, and the absolute value of -3 is in fact 3. So that also works. So these steps are what we should be going through, and we can circle these answers. Depending on your environment, you might circle those. They might want them in a solution set. Okay, just kind of depends on what curriculum preferences they have. All right, so on this we have a little bit more to do. In the blue box, I'm just trying to talk about the idea of how many answers we could have. We could have one answer if it equals 0, because that's the only option. Again, there is no opposite or -0, it's just 0. Most commonly, we have 2 answers, but it's possible to have no solution. So on this one, we only have it equal to 0. There is no opposite direction to go from 0. So I only have one equation, which we're going to solve by subtracting the 12 and dividing by the 3 to get x equals a -4. And we're just going to double check that up here. 3 times -4 plus 12, that's -12 plus 12, which is a 0. And that's 0. So it definitely works. we're good to go. Okay. So on this next one, we have all of the steps to go through. So I'm going to try and zoom back out here. For both of these down here, an extra step. We get to work with step number 1. Okay. And depending on what level you're learning this at, you may or may not have to deal with this step. We need to isolate the absolute value, which means everything inside those bars, those vertical bars, I need to get that part by itself first. So I'm not going to set it up to -4 and +4 to begin with. I can't say, oh, it equals -4, so it's no solution right now. I have to wait to do that. Okay, so I'm going to isolate the absolute value bars. And as it turns out, it's now equal to a positive number. So I should be able to come up with 2 options. If I was traveling 6 spaces from 0, I could either end up exactly at 6. If I went in the negative direction, I would end up at -6, or it's the opposite of that value. And we're going to solve it and check our answers. So I'm going to subtract the 9s and divide by 3. Same thing over here. I'm going to subtract the 9 and divide by 3. And then I should really double check my answers. Okay, so if I take 3 times -1, it's -3 plus 9 is 6, which has the absolute value of 6, minus 10. That is in fact -4, so it works, as does the -5. So double check the answers there. They both work. And similarly, we could do this one over here. And so to isolate, the first thing we have to do is divide by -4. So if I divide both sides by -4, I have the absolute value of 7 minus 6k equals a -7/2, or -3.5. If you were to go ahead and set up the 2 different equations for this one, what you would likely do, and some people just get in the habit of always doing this, you set it up equal to the -7/2 or -3.5, as well as the +3.5, because it's the opposite sign. Okay, now I'm going to go ahead and solve this just because. All right, so I'm going to subtract the 7. And divide by the -6, which makes it a positive 21/12. Okay. We could do the same thing over here. We subtract the 7. It's going to be a -7/2. Divide by the -6. I get a positive 7/12. So these are my 2 improper answers, but if I go back and I check them, it does not work. Okay? It does not work. So in reality, this is no solution. So you could work it out and check your answers. Okay? Your other option would be to analyze it when you have it isolated. When this was isolated, it was a negative. I cannot travel -3.5 spaces from 0, can't travel a negative distance, so I would have known right then it was no solution. Thank you for watching.